Hi guys, it's Miss Simon. So I wanted to make this video today to help you guys out with science. So remember yesterday we started talking about electric forces and we learned that electric forces have both positive and negative charges. And everything around us and everything, including our hair, our clothes, us, we have electric force. But normally we notice we're not attracted to the wall or attracted to someone else, and we don't get pulled in by the wall because our electric force is zero. It's neutral. Okay. That's why we don't find ourselves being pulled into the wall because our hair and our bodies and all of those sorts of things, we have the same amount of positive charges in us as negative charges. So we are neutral and we have no charge. So today we're going to talk about a little bit more about that electric force and those charges. So I'm going to share my screen and follow along. Make sure if I highlight it, you put it down in your notes. All right, so I want us to think of a balloon, okay? I have a balloon in my hand, okay? If I blow up a balloon and I put it next to a wall, is it gonna stick? All right, so we should see there that immediately, no, okay? It's not going to stick if I just blow up a balloon and put it next to the wall. So most of the time, objects like your hair and the balloon have the same amount of positive charges as negative. So they're neutral and there's no electric force to move them. Okay, so like we said, since the positive and negative charges are the same, it's not going to stick to the wall because it has a neutral force. So how might I make this balloon stick to the wall? Think about what I might do. Well, I could rub the balloon on my hair and then put it next to the wall. Okay, so let's see. I've rubbed the balloon on my hair. So now I'm transferring some of those charges. And when I put it next to the wall, we notice it sticks. So how do I kind of explain that? Well, first, the friction of rubbing the balloon moved a bunch of negative charges from your hair to the balloon. This made the balloon negatively charged. Okay, so in this picture, we see that we have the same amount of positive charges as we do negative charges. But then when I rubbed the balloon on my hair, I took the negative charges from the balloon and from my hair and transferred them to the balloon. Now, when you place the balloon near the wall, it pushes away the negative charges into the wall and it leaves the positive charges near the balloon. So immediately, remember we talked about positive and negative are attracted to each other. So these positive charges on the wall surface now attract the balloon. So the balloon is going to stick to the wall. Go ahead, and it's very helpful if we put this down in our notes, this picture here, guys, because we can see the negative charges are in the balloon are pulling the positive charges, and then the balloon is able to stick to the wall. All right, another way to think of it is as you rub a balloon on your head, you're charging it by giving it a negative charge. Okay, so me, by rubbing this balloon on my head, I'm charging it. I'm giving it more negative charges. Okay, so this is going to turn the balloon into one giant negative charge. Okay, this causes the positive charges in the wall to pull and be attracted to the balloon. Because remember, negative and positive, opposite charges attract each other. So it's going to pull all the positive charges to the wall, and it's going to attract it because you have negative and positive charges together. So remember, opposite charges attract. All right, moving on. So electric force is not just limited to balloons. Okay, this also applies to many other objects. So remember, we talked about when your pet's hair sticks on your clothes. So I want you guys to kind of think of what are some other examples of this transfer of electric charges that happens. What's another example you can maybe think of? I know some of us might have said when you're going down a slide and a person's hair stands up, okay? The electric charges are being transferred from the slide to the person, so that causes their hair to stand up. All right, so with this website, guys, and I'm going to include this on the assignment for today, okay? We're able to really see how the charges are transferred, okay, from the balloon to the sweater. When the balloon rubs against the sweater, it grabs the negative charges and then is able to stick to the wall. So let's look and see an example. All right, so I have my balloon in the center here. And if I move it over to the sweater, so I'm rubbing it on the sweater, we see all of these electric charges, these negative electric charges that it's picking up. So now I have all of these negative electric charges. So as I move it closer to the wall, all of the positive charges are now going to be pulled to the side of the wall and it's going to stick. And as we can see that happening, it sticks to the wall because again, positive and negative attract each other. All right, so let's go over these. If you put a balloon with negative charges next to a sweater with positive charges, the balloon will move towards the sweater. True or false? I'm putting a balloon with negative next to a sweater with positive. Are they going to stick together? You should have said true. Remember, positive and negative attract each other. They're going to stick. Which statement about electric force is true? Electrical charges, both positive and negative, can be transferred from one item to another. Only positive charges can be transferred. Positive and negative electrical charges cannot be transferred, or only negative electrical charges can be transferred. What did we see on those examples? What was the charge that was transferred? If you said D, only negative electrical charges can be transferred, you are correct. If you put a comb with positive charges next to another comb with positive charges, they're going to move towards each other, true or false. So positive and positive are positive and positive going to attract. If you said false, you are correct. All right, guys, so I hope that video was helpful. That was kind of just a visual to have you see that positive and negative are always going to attract. Positive and positive, okay, they're not going to attract, they're going to repel. Negative and negative are always going to repel. Bye, guys. See you later.